Hi, my name is Ryan Miller. I'm the technical lead of a data collection team here at Sumo Logic.
Hi, my name is Maisie Wang. I'm also an engineer in the same team, data collection.
And we'll be talking today about collecting at scale, tailing beyond the text file. When we traditionally think of collection strategies, we picture servers, writing to log files on a disk. And then for Sumo, of course, we recommend installing an agent. We call it the collector. The collector then sends the log data up to the Sumo cloud. But for this talk, we really wanted to focus on some of the emerging trends around new ways of producing data, as well as the challenges that arise when it comes time to collect that data. So if we look at increasing levels of scale, we see that installed collectors, they fit really nicely into the sort of traditional server environments, sort of the three items above the line. If we start with a base case of a single machine, at this point, you can probably get by with simply tailing, a log file and grepping for the messages. But as your application grows, as your cluster grows, we of course recommend installing collector agents that can then send the data up to Sumo and sort of centralize it within the cloud. As your application grows further and your clusters become hundreds of machines, at this point you're probably going to be looking into sort of automation frameworks, tools like Chef and Puppet. If you're on AWS, you may even bake the collector image into the machine image, or AMI. And of course we offer collection management APIs, where you can manage collectors, add sources, make modifications in a scripted, sort of automated workflow. But if we start looking at sort of cloud-native platforms, things like AWS S3 buckets, serverless functions like AWS Lambda, how do we go about collecting logs, from these services when there's actually no server to install a collector on? So with these services, they enable sort of unprecedented levels of scale, but that also opens new challenges when it comes time to collect that data. And I forgot that. So that's really what we're going to focus on in this talk. And sort of the premise of today's talk is that these new ways of generating data require new ways of collecting it. So the three key takeaways that we'd like you to walk away from this session with. First, we're going to cover our Amazon S3 source and showcase some of the new features that we've been working on, improving the performance, the security, and the ability to automate your workflows using CloudFormation templates. Second, we're going to be looking into using the HTTP source and how it can integrate with a wide variety of applications. We'll cover GCP, or Google Cloud Platform, as well as sort of a deeper dive into AWS Lambda and monitoring serverless functions as a whole. And last, we're going to give a sneak peek of some of the cool things we're working on the data collection team, and sort of preview some of the features of upcoming projects that we'll be releasing.
So let's take a look at some numbers here. Of all the data that gets sent to Sumo, almost half, or around 46% of it, is coming from the cloud. So rest of it is coming from our installed collectors. So we can see that cloud collection is really becoming a in Sumo here. Test. All right. Sorry about that. So let's take a look at some of the numbers here. So of all the data that gets sent to Sumo, almost half, or 46% of it, is coming from the cloud. So we can see that cloud collection is really becoming a really big portion of what we're dealing with at data collection at Sumo here. So The majority of the data from the cloud is either from the AWS S3 or from HTTP requests. And our largest S3 customer is sending us over 75 terabytes of data on a daily basis. So we want to take a closer look at the S3 collection in Sumo. Specifically, what are we collecting from S3 and how we are collecting from it. So S3 is really a centralized repository for logs coming from your different AWS resources. First, we have the ELB writing its access logs to your S3 buckets. So ELB writes so those are the access logs of all your network requests that go through your load balancers. Then we have the CloudFront writing logs to your AWS S3 buckets as well. So CloudFront is a content delivery network that allows for easier delivery of your content to your end users. And it writes information on all of your user requests to S3. We also have the CloudTrail service writing to S3. So CloudTrail is a management tool that records all the API calls made in your AWS account. We also have the S3 audit. So those are the activity logs about your S3 buckets. And of course, your custom data. So those are data that you might be putting and storing in your S3 buckets from anywhere. You might be running some services on your EC2 instances, and they're writing logs to your S3 buckets. So we're looking at like 4 or 5 different AWS resources here, but under the hood, they're all writing logs to S3. Over the last 2 years, we saw a 500% increase in the S3 ingestion alone in Sumo. So that's a really significant growth rate. And how does Sumo keep up with this kind of growth? Next, we'll be talking about several new improvements that we made around S3 collection to help with scalability as you scale your infrastructure.
Yes, so we're very excited to talk about some of the new features we've been adding to our S3 source. First, we're going to cover some of the performance improvements, the largest of which is switching to a new push-based model. We're calling it the event-based or SNS-based model for S3 collection. This enables lower latency from the time your objects are created to the time they're visible within Sumo Logic. Next, we're going to cover some of our new security best practices, including the introduction of IAM role support for our S3 source. And last, we're going to cover automating your workflow using CloudFormation templates and the ability to generate these templates with a single click within Sumo Logic. So first, in terms of performance, we have seen a bottleneck when it comes to S3, especially when it comes to scanning large S3 buckets. In fact, we had a customer with 40 million S3 objects in their bucket. Scanning took over 7 hours. So this raised or increased the time it took to discover new objects. So this gave way to a new model when it comes to S3 collection. This push-based model relies on an SNS subscription and a topic, so that Sumo actually gets notified when new objects are created in your bucket. So for that customer with 40 million objects, it actually reduced the time for them to see their data within Sumo from that 7 hours down to around 2 minutes. We just finished the beta program for this new feature. 23 customers participated, and the largest customer was actually ingesting around 300 objects per second, which comes out to around 25 million objects per day.
So how does Sumo access your AWS sources? Previously, when you're setting up an AWS source, you will first need to create an IAM user in your AWS account. And then you want to specify a set of permission policies to allow Sumo to read and download your S3 objects. And then you want to create an access key on the IAM user and provide that access key to Sumo. But access keys are really long-term credentials that are not meant to be shared to third-party services like Sumo. Although your access keys are encrypted in Sumo, why not just eliminate the use of access keys at all? So the IAM role-based authentication is a perfect solution for that. So IAM roles allow third-party services like Sumo to request for temporary security credentials that last for at most 1 hour by assuming the IAM role you create in your AWS account. So for the IAM role, you first need to specify the same set of permission policies as I mentioned earlier, similar to how you set up the IAM user. You also need to specify a trust relationship between your AWS account and Sumo's AWS account. So currently this feature is available for all of our AWS sources, not just S3, but also the AWS metadata and the AWS CloudWatch metric source. We are also looking to enable it for our S3 data forwarding in the near term. So let's take a look at how exactly this authentication works. In your AWS account, you have the IAM user that trusts Sumo's AWS account and only Sumo's AWS account. It also grants permissions on a number of actions that Sumo will be performing in order to ingest your S3 objects. Next, you want to provide Sumo with the role ARN, which is a unique identifier for your IAM role. And then Sumo's EC2 instances will make an API call to assume that role and get a pair of security credentials, temporary security credentials that inherit the same permission you set on the IAM role. And then it will use the credential to access your AWS resources. And then after the credentials expire, Sumo will make additional call to assume the role and get new credentials. So you might be wondering what exactly do you need to set up this IAM role, like what permission policies you need, or what information you need to set up the trust relationship. Or you might be interested into automating the process of deploying your IAM roles. So CloudFormation is a good solution for that. CloudFormation is a tool in AWS that lets you manage your AWS infrastructures in these units called stacks. And a stack is defined by a group of AWS resources and dependencies in a template file, either in JSON or YAML. So with these template files, you'll be able to create, modify, or replicate your AWS infrastructure in CloudFormation. So Sumo provides a CloudFormation template for creating the IAM role needed for the role-based authentication, as well as a template for creating the SNS subscription and the topic needed for the event-based S3 collection that Ryan just mentioned about. So after you fill out the information of the S3 bucket that you want Sumo to be collecting from, you'll be able to generate the template by clicking these buttons. After that, you'll be able to view the template, download the template, and make modifications to it based on your needs. And then you can upload the template to the CloudFormation console and deploy your AWS resources.
So in addition to our S3 source, which again is a way to bring in sort of all data from your S3 buckets, we also wanted to highlight our HTTP source, which similar to S3 is sort of a catch-all that can be used for many different applications. So we kind of wanted to give a sort of a workflow of how you might integrate the HTTP source into a serverless application. This is sort of uncharted territory when it comes to collecting data. It's very different from the standard approach of installing a collector, tailing a text file. With Lambda functions, which are these very short-lived invocations that may live for only milliseconds, but they generate log messages that, of course, we want to preserve and bring into Sumo. So how do we go about integrating, Lambda, AWS Lambda, with Sumo? There's actually several different approaches, and each of these would suffice. They all do the same thing, which is bring the log data into Sumo. I did want to break it out into 3 different approaches to show how your solution or your infrastructure might evolve over time. Starting with the simplest approach, because it is code, it is a function, You can, of course, do an HTTP post directly from your Lambda function, and we'll talk about some of the pros and cons of doing it that way. As your infrastructure grows, as you're reaching more scalability limits, we recommend integrating CloudWatch logs into the workflow. And then lastly, we can integrate even more infrastructure, such as AWS Kinesis, to add a message queue to support even greater levels of scale. Whoops. Oh, I think I missed one. There we go. Okay. So again, breaking these down into sort of the three different types. With that simplest approach, posting directly from your Lambda function, this is ideal for debugging environments, sort of one-off use cases as a way to quickly get the data into Sumo. The biggest downside to doing it this way is that the invocation or the HTTP post would be synchronous. So as you're paying for your Lambda invocation, you're also paying to send the data to Sumo, as well as the potentially slowing down your application logic as it waits for the HTTP post request. CloudWatch logs offers a great way to asynchronously write to a log stream. So simply writing to CloudWatch logs and then forwarding the data to Sumo allows you to sort of overcome that synchronous bottleneck. The downside for using CloudWatch logs by itself is that CloudWatch logs, and in fact all Lambda functions in general, have a concurrency limit. So with AWS per region, it's 1,000 concurrency limit. So you're sort of limited in the types of throughput you could achieve when it comes to your concurrent Lambda invocations. But after this, if you introduce Kinesis, or really any message queue, but I did want to highlight the use of Kinesis here. With Kinesis, it gives you control over the concurrency. So with your Lambda functions, you could have them concurrently run with your Kinesis shards. And as well as with the asynchronous message queue, you could introduce things like batching to minimize the overhead of HTTP requests. So you could send larger batches and less often to Sumo. But what's really cool with all of these approaches, it's actually the same Sumo HTTP source. Notice we haven't changed anything on the Sumo side. So this is just sort of showing the versatility of the HTTP source and how it can integrate with many different workflows. So I skipped this slide earlier, so I'm actually going to go back to it here. Kind of an overview of that HTTP source. At Sumo, we're seeing around 90,000 HTTP requests per second. And year over year, we've seen over a 60% growth in just the sheer number of HTTP sources. So many customers are making use of this way to get data into Sumo. And lastly, Sumo, on our GitHub repo, we offer 13 different open source clients that integrate with all of the tools you see here, as well as several others. Even other agents like FluentD or Logstash. So if you are using FluentD, if you're using Logstash, we actually have an HTTP output plugin that makes use of our HTTP source, and it will send the data to Sumo. We integrate with programming language frameworks. I wanted to highlight our .NET appender, as well as our Log4j appender. So this would cover any C# environment, Java environment. You can actually emit your logs directly using these open source clients. We have a Docker logging plugin. So if you are using Docker containers, if you have very ephemeral, short-lived containers you don't want to mess with installing a collector, you can use our Docker logging plugin to send the logs. And under the hood, it's actually using the HTTP source to transmit the log data. And Lambda, of course, is what we just talked about. We did a deep dive into Lambda and Kinesis. Let me skip back over that.
So Google Cloud Platform is another cloud service provider that's been gaining popularities over the recent years. And if you're running services in your GCP account, you might be interested in sending your data from your GCP services to Sumo. How can you do that? So in Google, you can utilize the Google Stack driver, which is a tool that where you can export your data from your GCP services to Google's real-time messaging service, PubSub. And from there, you can create a subscription in your PubSub to have data pushed to Sumo using HTTP webhook. So recently, we made a new integration with GCP to help you with a guided HTTP source setup. And currently, this source is used by over 70 customers that are sending data from their GCP account to Sumo. So taking a closer look at how to set up this GCP source. So it's essentially an HTTP source with some information specific to GCP. So first, at the top here, you have the usual source metadata like the name, description, source host, source category. But the most important part is the log discovery setup. So first thing you need to do is to create an URL endpoint. And this URL endpoint will be used for two things. First, you need to create a notification subscription on the PubSub account using this URL. You also want to add this URL to the list of allowed domains in your Google account. And when you do that, Google will ask you to upload a verification file in HTML to kind of verify the domain, the ownership of this domain. But this domain is really owned by Sumo, so all you need to do is to provide Sumo with the name and the contents of the verification file. So after this, Sumo will be able to receive the data pushed from PubSub, and you can start exporting the data from Google Stack driver. So after you set up your source, you can start monitoring your Google Cloud Platform services in Sumo. You can install some of the pre-configured apps that we provide to you. So these are pre-configured dashboards to help you monitor your GCP service. So here is an example of a dashboard for the Google App Engine. So you have some information like where the requests are coming from and a lot of useful stuff. And then we have an example of the Google Cloud Load Balancing dashboard. You also have a similar graph on the request location, and you can see some status codes returned from your load balancers. We also have an example of the IAM dashboard. So this one shows like the operations on the IAM console and the IAM role activities. So these are all really useful information when you start monitoring your GCP services.
So as we start to wrap up our talk, we did want to give a preview of some of the cool things that data collection team has been working on. So we wanted to preview 3 features today. The first is actually a project that Maisie and I are working on together. It's called Ingest Budgets. Ingest Budgets is a way to control your cost. We've had many requests of a way of basically keeping control over their ingestion into Sumo. So Ingest Budgets is a way to sort of budget your quota such that your dev environment has no way of affecting your production environment. Using ingest budgets, then you can sort of take control of your costs as well as limit groups of collectors to how much they can send on a daily limit. This feature is in beta now, and in fact in the next slide or in the coming slides we'll give an email link if you are interested in participating in the beta for ingest budgets. Second, we wanted to talk a little bit about metadata. You've probably heard metadata discussed at some of the presentations already today. We are working on key value support for logs. So we've always had support for things like source name, source category, source host, but we do want to expand that to support sort of arbitrary key value pairs that make it easier for you to both tag your data and then also query your data and sort of make sense of all of the data that's coming into Sumo. In the same line with metadata, we're working on our metrics project. We've heard this morning about our unified logs and metrics experience. When it comes to CloudWatch metrics, we've already been ingesting things like EC2 tags. EC2 tags, of course, are key value pairs that AWS assigns, or AWS allows you to assign. We are going to add support for all namespaces. So if you tagged, let's say, your RDS instances or your load balancers, we will ingest those tags as well and make them searchable within Sumo. This has been very requested as a way of making sense of all of the CloudWatch metrics, but also to filter exactly the CloudWatch metrics that you're interested in consuming into Sumo. This feature is still in development. It's coming soon. Just be on the lookout for that one. And lastly, again related to metrics, we've been working on supporting new formats. So currently, Sumo supports two formats, the Graphite metric format as well as the Carbon 2.0 format. We've seen increased adoption around Prometheus, using Prometheus as a metric backend, and we're going to be adding native Prometheus support into our HTTP source as well as our collector streaming metric source. And this will allow you to simply export your metrics directly from Prometheus into Sumo Logic so that you can query your metrics that way, and you can also create dashboards and alerts on top of those. And this feature is also in development and is coming soon.
So to summarize, we introduced you several different new improvements we made around cloud collection, focusing on S3 and HTTP. So to get better performance for your S3 collection, we're moving away from the poll-based approach that doesn't really scale well with large buckets to the new event-based approach that can drastically improve the discovery time of your S3 objects. We also introduced a new way to authenticate your AWS sources with the use of IAM Roles, and that's also to follow Amazon's security best practices. So to make the setup process of both the event-based S3 and the IAM role authentication simpler, you can start using CloudFormation templates provided by Sumo. So for HTTP collection, we walked through several different ways of collecting data from your AWS Lambda functions, with the combination of CloudWatch logs and Kinesis being the most scalable solution. And last but not least, we introduced the new integration we made with the Google Cloud Platform. So if you're interested in the event-based S3 or the IAM role authentication, please visit our doc page to learn the detailed setup steps about how to set up these features. You can also check out our GitHub repo for the open source clients like Lambda, Docker, and a lot more. If you're interested in the ingest budget feature that Ryan just talked about, you can send us an email to this email address, and we'll have someone reach out to you and get you involved. Yeah. So thank you for coming to this talk, and we will open up for questions.
Thank you.
Right, thank you. If anybody has a question, please raise your hand and I'll give you a mic.
For the HTTP collection expansion you guys are doing, working towards natively supporting things, is there anything in the works with Kubernetes as far as natively supporting streaming its logging output to the HTTP, or is there already something in place for that?
Yes. Okay. So the question is about how are we supporting Kubernetes with our HTTP source. We do have an open source project. That's one of our open source plugins, actually. It's built into Fluentd, or I should say it's built on top of Fluentd, but it's able to call a few of the Kubernetes APIs. I believe they have a tagging system to tag things like pods and containers, and that's actually available today. So I recommend checking out the Sumo Logic GitHub page, and then if you search just Kubernetes, one of our sales engineers, now product manager, Frank Reno, is actually working on that project. And along with our metadata support, we're looking into integrating that sort of tagging from Kubernetes, definitely.
Thank you.
Thanks.
Thank you. Nice question. Rick?
Hi, with the ingestion of tags, is that going to be linked back to the collectors that are EC2 instances, or is it just for CloudWatch metrics?
That's a great question. So with the CloudWatch metrics source, we are already today ingesting things like EC2 tags. Once we introduce log key value pairs, we fully intend to start ingesting those EC2 tags. Let's say if you have a collector installed on an EC2 instance, we think it makes sense to sort of union or join those two data streams. And that's coming soon with our log metadata support.
Thank you for your speakers.
Thank you.
Thank you.